go. Okay, but to start us off, I want to do a little review of absolute value.
I'm sorry, Mr. Aguilar. Is there any way you can make it bigger? I can't really see it. There you go.
Is that
Yeah,
better?
thank you.
Okay. Absolute value. So what I'm going to ask you to do is find the absolute value of the given expressions. So the first one is find the absolute value of 6. The next one is the absolute value of -22. Then we want to find the absolute value of -1/4. And finally, find the absolute value, the negative absolute value of -1/4.
Hey, sir, is there a participation grade in this class?
Is there a participation grade in this class? You mean like participating in the lecture?
Like if you give us problems, like we would have to solve it and stuff, does that count as points or is it just our attendance? Because I am back on the road again, that's why I'm asking.
Oh, okay, I see what you're saying. So the grade is outlined, the way the grade is broken down is outlined in the syllabus, so I'm just going to refer you to that. But as far as like attendance is based on not only are you here in the Zoom lectures, but are you making substantial progress along the correct timeline that is given out in the orientation module. So if you are keeping up with your homework, I can see how much activity you're putting into MyLab Math, and I check that regularly. And that's how I determine the attendance. The specifics, again, are in the syllabus and in the orientation module. But for these problems that we do in class, I just expect you guys to show up and take notes. Because if you're not doing that, then you're going to do a lot more, where you're just going to have more of a challenge on the homework and then on the test. So,
okay, just making sure.
Yeah, you got it.
Okay.
If for whatever reason you have to miss class for a doctor's appointment, you have to pick up a kid, you're on the road, you're traveling, do not feel obligated to just pop in if you're driving or at the supermarket or something like that. There's absolutely no point in even coming to class if you have other things going on that are taking a priority. Again, the video lectures are posted to Canvas after class each day, so you can always just review them later. Just shoot me a courtesy message beforehand if you know that you're going to be absent. Okay, back to the relevant topics at hand. If you guys can take a few moments now, or if you have already, take a few more moments to look at these problems and then solve and give the absolute value of each of these problems.
Would you like a good evening, Professor? Would you like us to write it in the chat?
Yeah, if you come up with the answers, you can write them in the chat for sure.
Okay. I only have 1 and 2. I'm a little perplexed on 3 and 4, so I'm gonna just write those for now.
Okay. Yeah, it seems like we're doing pretty good here. We are developing a consensus that the first one should be 6. That's the absolute value of 6. If you don't remember, the absolute value refers to the distance a number is from 0 on the number line. So the absolute value of +6 is it is 6 units away from 0 on the number line. So that should be 6. Number 2 should be +22. And does anybody have the absolute value of negative 1/4? Does anybody want to venture a guess?
Is this one of those scenarios where we have to turn the fraction into either a decimal or whole number of sorts?
No, not at all.
Okay, that was my only guess.
Yeah, no, good question.
So I'm gonna think maybe then just keeping it as it is, then it should become positive 1/4.
Yeah, absolutely. That's
Oh,
right.
okay, right on.
Right,
I was
because
looking-
we're just pulling out our tape measure. We only measure distances in positive values. So if like you wanted to measure something that was an inch to or a quarter inch to your right, you would pull the tape measure out a quarter inch. And if you wanted to measure something that was a quarter inch to your left in the negative direction, you would pull your tape measure out a quarter inch, and it would still say 1/4 of an inch. So distances are what we should be thinking about when we're trying to apply the absolute value. So it doesn't matter what this value is. If we're trying to measure the distance that this value is from 0, it's a positive distance. Now, the last one should have been a little bit trickier because we really have two operations in this problem. The first one is that we need to apply the absolute value of negative 1/4. So you can think of it like a quarter inch to your left. But that has a distance of 1/4 still. So we could write this as 1/4, applying that absolute value operation. But then we still have this negative sign on the outside, which last time in class, we said that that's sort of like multiplying by -1. So if we still have that multiplication to do, then when we simplify this problem, really we should get negative 1/4. So you should sort of look at that, and even though it looked like maybe one operation, we should be thinking about it as two operations and then correctly applying our order of operations. Order of operations says that we do all the stuff in the grouping symbol, the absolute value bars, apply the absolute value operation, and then we can multiply by the -1 after that. And that's how we get negative 1/4 for this one. So just be very careful with that. Because
So I had a question.
it looked very similar to number 3. Yeah, what's your question?
So anything outside the line is going to be multiplied?
If there is not an operation symbol explicitly stated, then yeah, it will be multiplication. Like if I had, for instance, let me go ahead and make a fifth problem up, right? 3 times the absolute value of -1/2. I mean, I just gave it away because I read it as 3 times the absolute value of -1/2, right? In this case, I would say that this is 3. The absolute value of -1/2 is 1/2. So then I don't have an operation written here between the 3 and the absolute value bars. So that's implied multiplication. It's the default operation. So I can multiply this out and I should get 3/2. Similarly, if I have, let's say, -4, and then the absolute value of, let's say, 1/8. Well, I need to do my grouping symbol stuff first. So the absolute value of 1/8, this part here, is just 1/8. But then I need to multiply that by the -4 out here. So I should be getting -4/8. And then you have to remember to simplify this fraction. So we should get -1/2 as our final answer. Any questions about that? Cool. Okay, so we're moving on. I've talked about expressions with variables a few times already. I'm going to just sort of reiterate what a variable is. So a variable is a placeholder for an unknown value.
I can't see your notes. You zoomed in too much.
You're absolutely right.
Thank you, Professor.
Okay. So when we're given an expression that has variables, and when we're given the value of the variable, we can plug in the value of the variable, that is substitute in the value, and then we can simplify the expression, because now it would be a purely numerical expression. So for instance, if I had, I think I used this example in the past, if I went to the supermarket and bought 3 apples plus 2 bananas, and then I got maybe 4 pineapples. Right now, I don't know what the cost of apples, bananas, and pineapples are, so I really can't simplify this expression any further until I have some extra information. But if I were to tell you that apples cost $1, for some reason these monstrous bananas cost $2, and then we're in some weird abstract mathematical land where pineapples cost a negative amount of money. That is, they are paying us to take their pineapples away. So we're paying negative $3 for the pineapples. That is, they're giving us $3. Weird way to think about it. In any case, those kinds of things don't happen in the real world, but they do happen in mathematical worlds. Well, now that we've been given the values for our variables, we can substitute them back into the expression and then simplify it. This is called evaluating the expression. Okay, so now we can take 1, which is the value of A, and plug it in for the A. We can take the 2, plug it in for the B, and take the 3 and plug that in for the P. And when I say plug them in or substitute, what I mean is we're going to write the expression down again, but every place that you had a variable, you will open up a set of parentheses and then stick that value in for the corresponding variable. So if A is worth 1, we're going to put a 1 here, plus 2, then parentheses 2, since that is the value of B, plus 4, and then the value of P was negative 3. Now, when I wrote this down, I really avoided saying times because I wanted to sort of hold the secret back from you guys. But what we're doing here is when we say 3 and then parentheses 1, you should never read it that way. You should read it to yourself as 3 times 1. It's going to make your life a lot easier because that's the operation that's happening here. 3 apples is 3 times the cost of 1 apple. So that's how we need to think about this. 3 times 1 plus 2 times 2 plus 4 times 3. Or negative 3. And so now that we have a purely numeric expression, we can use our order of operations, simplify each of the little parts, and then get our single numeric answer. So we should be able to multiply 3 times 1, get 3. 2 times 2 gives us 4. 4 times negative 3 should be negative 12. Then we can just do our addition and subtraction left to right since they have the same priority in terms of our order of operations. So this is 7 minus 12. So 1 operation left. We can go ahead and do the subtraction, and we should get negative 5. Does anybody have any questions about that one?
No, sir.
Cool.
Yeah, I would have messed up some way by that positive that you deleted to get I could see myself messing up with that positive that you got rid of for the -12.
Oh, yeah, this
I
right
mean,
here.
not the positive, yeah, the plus sign, right.
Yeah,
I would
well,
have totally messed that up.
when you're multiplying this, you could have put plus -12.
Oh, I could have.
Yeah, because if you
Oh.
add a negative number, that's the same thing as subtracting. But it's just simpler to just say subtract instead of
Gotcha. So that
plus
was the way I
negative.
was gonna go when I was answering in my head. And then you
Yeah.
deleted it. I was like, oh, damn, I would have got that wrong. But okay, I would have still been in the same answer field
Yeah,
if
you
I
would have
would have done
been
it that way.
you would
Okay,
have
cool.
you would have been on the same track unless you did something weird with adding a negative number. Right. So
Gotcha.
if in your head, like adding a negative number seems a little bit trickier, plus a negative number, you should just convert to your head as subtract.
Awesome. Thank you, Professor.
You got it. Okay, let's look at some of these. Get some practice problems in. Evaluate the following. Given x is equal to -2, y is equal to 5, and z is equal to -3. So the first one is -4x squared minus 7y plus 4z. Ooh. Lost the instructions there for a second. So take a moment to solve that one or to evaluate the expression given these values for the variables and see what we come up with.
Hey man, you fuck ass nigga. You stink, you bitch. Get the fuck out my face, you bitch. Oh my god, you bitch. Oh my god, you bitch. Oh, I love you, daddy. What? Hey, your head.
Okay, the recording is resumed, and let me go ahead and share my screen so we can keep working on this problem. All right. Has anybody simplified this expression already?
Yeah, the
What did you get for this?
oh, you mean I haven't completely answered it. No, I'm sorry. I just broke
Okay.
it. I just converted it all to something that I can work on now.
Okay, yeah. So we've substituted the variable values in. Well, if anybody is sort of nearing completion of this problem, you can go ahead and type whatever you got for your final answer in the chat. Oh, cool. A few people finishing that up. And it looks like we got some sort of consensus here that it should be -63. Let's see if that's correct. So let's go ahead and plug this in. X is -2, so I'm going to go ahead and write that squared. Minus 7 times y, which is 5, plus 4z, which is -3. And then I need to be really careful about my order of operations here. So let me go ahead and zoom in just so that we can see what I'm doing. All right, so I have a bunch of operations here. The first thing that I want to take care of is maybe writing GEMDOS down to guide us. And in my head, I want to take care of the exponent before I take care of anything else. So I'll go ahead and do that. This is -2 squared. So that should be -2 times itself, which should be +4. So I'm going to take that result, +4, and I still have this -4 out here. So I need to multiply that at some point. Let me go ahead and write everything else out. Okay, well now it looks like I just have subtraction, addition, and a bunch of rounds of multiplication. So I'll go ahead and take care of the multiplication next. Here, here, and here. And if I multiply this out, I should get -16. I'm going to put a minus sign down. I'm going to call this 35. And I'm going to call this -12. Well, you could drop this plus sign, I was going to say positive, this plus sign down. And if you do that, just so that you don't get confused, this is a -12 since 4 times a -3 gives you -12. You might throw that in parentheses just for clarification or for clarity's sake, but some students find that more confusing. So as opposed to putting, plus, minus, and parentheses, I just think it's easier to write it as -16 minus 35 than -12. So if we go ahead and do all that subtraction, if I have -$16 in my bank account and I spend $35 that I don't have, I should have a bigger negative number. And then I spend another $12. So I should have a large negative sum, right? Well, I'm just going to throw this in the calculator as opposed to doing this, by hand. And I should get -63. So it looks like you guys were on the right track for the most part. Does anybody have any questions about that?
Yeah, I got -31. I mean, I got +31. I don't know
How'd
why.
you get +31?
Well, that's what I got on my calculator, but my scientific calculator is not here yet. I'm using my cell phone.
Oh, I see. Yeah. When you're using the cell phone calculator, you have to be really careful. Most times you have to type the number and then hit the negative button.
Yeah, I did that. I don't know why I put negatives. I put -16. Let me do this again. -16 minus.
-35.
Oh, see, I put minus, then I hit the negative sign again and put 35. Would that have made a difference?
Yeah, absolutely. Because if you subtract a negative, you're adding a positive number.
Gotcha. So that's where I went wrong. See, every time I went to the next number, I'd hit the negative and then I put the symbol for what we're trying to do.
Yes. So to resolve that issue, you need to type into the calculator exactly what you've written down. When you just read this out to me, you said you put -16,
Yes.
and then you said minus a -35, but this is minus a +35.
Minus 35.
So just type it in exactly the way you wrote it down. Don't add any additional negative signs. Again, when I type this into my calculator, -16 just to start off the line, but then it's just -35 minus 12, and you get the final result of -63.
I see where I went wrong. I put the minus and then I put negative following it. Yeah.
It's
I
a very
changed the
common
whole-
mistake. Students make it all the time. You just, I think I might have said this before, but you have to be very careful. The calculator is a tool. It's not going to do the thinking for you. So whatever it spits out, if you don't put the right stuff in, it's not going to spit the right stuff out.
Gotcha. Thank you, sir.
You got it. Let's do a couple more. So let's practice these. Let's let x equal 19 and y equal negative 22. And we're just going to evaluate these expressions. And the expression I'm going to give you is the absolute value of x minus y. The second one I'm going to give you guys is x is equal to 2, y is equal to 3, and a is equal to negative 4. And you guys need to evaluate the expression 4x plus 4 times 3 plus a, that whole quantity is squared, all over y plus 1. Yeah, and we'll leave it at that. So I'm going to throw you guys into some breakout rooms so that you can talk this out amongst yourselves, and then I'll jump in and sort of help you guys out with that. Okay, I think most of us have made it back to the main session. Let's go ahead and evaluate these. The first one should have been pretty straightforward since it's just plugging in two values here into this absolute value expression we have. So let me give myself a little bit of room to solve this one. We said for number 1, and I know it's kind of blurry, let me go ahead and refocus that. We said let x equal to 19 and y equal to negative 22, and we wanted to evaluate the expression x minus y, the absolute value of that. So what I would start by doing is going ahead and taking the 19 here, plugging it in for x, taking the negative 22 here, plugging it in for y. So everything else in the problem, all the other structures or symbols that we see, they need to be maintained. So I'm going to keep the absolute value. But for the x, we can write 19, and I'll go ahead and write that in green, just so I can see what I plugged in, so 19. We had a minus sign that was originally in that problem, so we have to keep that. And then we're substituting in for y a negative 22 here. And then we can close up our absolute value bars. Does anybody have any questions about what I just wrote down?
No, Professor.
Okay, because if you made the mistake of saying, well, I already have a negative sign here, let me just write down 22, then you've forgotten one of the negative signs, right? This is a minus sign, this is a negative sign. There really isn't a difference between a minus and a negative sign, but we do need to write both of them. So when you're subtracting a negative amount, you can just think of that as an addition symbol, right? If I subtract a negative amount in the real world, that would be like me taking away your debt. So we can think of debts or amount of money that we owe as a negative value. And if I take away your debt, that's like me paying off your debt, me giving you money so that you can pay off your debt. So it's really more simple to write this as 19 plus 22. And that'll take care of this double negative thing here. So 19 plus 22 should be That's 11, one up, that's 20, that's, what is it? 41? Let me double check that. It's always good to double check. 41. So we have the absolute value of 41. But again, the absolute value is just returning the positive distance from 0. And since that's already a positive number, we're not going to really make any changes there. This is just going to be 41. We can drop the absolute values, the absolute value bars, and our simplified answer is 41. Does anybody have any questions, comments, or concerns about that problem?
Yeah, I did that wrong. I got rid of that negative and left the, I got rid of the negative next to the 22 and just left the symbol of subtract.
Yeah.
And so I got 3 as
Same
my
here.
answer.
Yeah, so you have to be really, really careful when you're substituting this value in for y, you're only substituting it in for the y. You're not substituting it in for the minus sign that was already there.
Yeah.
So just be careful with that. Okay. The second problem was a little bit more cumbersome. So let's see what our variables were. X is equal to 2, y was equal to +3, and a is equal to -4. So the expression we were working with was this large fraction 4x plus 4 times 3 plus a, that quantity squared, all over y plus 1. And so if you wanted to, you could write a game plan as far as our order of operations are concerned. Once we go ahead and substitute in these values, right? For our x, we're going to substitute the value 2. For y, we're going to substitute the value of 3. And then for a, we'll substitute the value of -4. So we might rewrite this expression, and everywhere that I had a variable, I might just go ahead and write an open set of parentheses because I'm going to plug a value in there. So 4 times something plus 4 times 3 plus something squared, all over something plus 1. And then I can just go ahead and substitute in those somethings. So this should have been our 2. This should be our 3. And then we should have a -4 here. Maybe the yellow is harder to see, so I'll just go ahead and write that one in, like so. Okay. Well, now I need to use my order of operations to figure out what I need to do first. So the first thing that I need to do is anything that I can do inside of grouping symbols. So in this case, if there's anything in the parentheses that I can solve first, that's what I will go ahead and simplify. So in my head, the stuff in here needs to be simplified first. Then we can take care of the exponent. We can take care of whatever multiplication there is. And then we can take care of any addition that we have left over. So if I'm just taking care of the stuff that's in this set of parentheses, that is 3 plus -4. So if I have $3 and I spend $4 that I don't have, I should have -1 there. So I'm going to write -1, which is left over here in the green. But I still have this exponent of 2 that I need to write down. And I'm going to write down the entire rest of the expression. So there's a 4 out here, plus a 4 times 2 in the front. And then we have 3 plus 1 on the bottom. Does anybody have any questions so far? Questions or comments?
How did you turn 3 plus the -4 with the exponent of 2 to the 4 times the negative?
Can you repeat that question for me?
How did you get the 4 times the negative?
Oh, there was a 4 here.
The -1.
Oh, how did I get the -1?
Yes.
Oh, I'm just doing 3 plus -4.
Oh, okay, never mind.
Yeah. No, there's a lot going on here, so don't worry about it. But 3 plus -4, if you were to throw that in the calculator, just that part, you should get -1. And again, if you have $3 and then you spent $4 in your debit card, well, you should be owing the bank $1, so -1. Okay, so I took care of my parentheses. Now I need to take care of the exponent. So we have -1 raised to the second power, which you have to remember, that's the same thing as -1 times itself. And a negative times a negative is a +1. So I can rewrite this whole problem as 4 times 2 plus 4 times now +1, since I took care of the exponent. And then we have 3 plus 1 on the bottom. Well, now I'll take care of the multiplication. So I can multiply out the 4 times 2 and the 4 times the 1, which will give me 8 plus 4 on top. And then we have 3 plus 1 on the bottom. And I'm just going to go ahead and drop the parentheses here because there's nothing to do with that 3. The parentheses are sort of excessive. We don't need them. And now we can just go ahead and take care of this addition. So we should get 12 here on top over 4. But last time I said that if we need to simplify this fraction, we could divide out a common factor. But if we think about our fraction as a division problem instead, it'll be easier in this case to simplify this because we're really just looking at 12 divided by 4. So in this case, our final answer should just be 3. Anybody have any questions? Okay. Well, now we're going to change our attention to talk about a property that's going to be very useful for us. And that is called the distributive property. You might have noticed that when it comes to multiplication, in the past, we've used, maybe in grade school, you use the symbol X to identify multiplication. But we also use a dot to indicate multiplication. And then sometimes we use parentheses to indicate multiplication. These are all valid symbols that can be used for multiplication, but typically in this class, we won't be using the X symbol anymore since we have a variable that may at times be an X. So that would just be a little bit confusing. So when we multiply values, as we've seen when we substitute a value in for a variable, we might have expressions that look like 4 and then parentheses 3. And in your head, you have to interpret that as 4 times 3. 4 times 3. As parentheses will sort of be one of our preferred forms of writing multiplication. And then we can work that out in our heads and get 12. But sometimes you will have a number outside of the parentheses. So example, let's say we had 4 times a set of terms or a set of numbers in the parentheses that may be added or subtracted. So we could have like 5 plus 3 in here. And so this distributive property can be used in place of doing solving the stuff in the parentheses first. So it can be used in conjunction with our order of operations. So our order of operations would typically say, simplify everything in the parentheses first, and then do the multiplication after that. So we could do that using GEMDOS. And we would get 4 times, in this case, 8. And then 4 times 8 is what, 32? And that would be the simplified answer for that particular expression. But we could also use the distributive property here, which I haven't described yet, but I'll go ahead and demonstrate it. 4 times 5 plus 3. The distributive property would have us take the 4 and then multiply it across this addition problem here. And what I mean by that is we would then write this as 4 times 5 plus 4 times 3. And that kind of multiplication with those smaller numbers are a little bit easier to do in our heads. 4 times 5 is 20 plus 4 times 3 should be 12. And when we go ahead and complete the addition after distributing, we get the exact same thing, 32. So our simplified expression is going to be the same, regardless of whether we use the strict order of operations through GEMDOS or if we use the distributive property. So you might be asking, why am I giving you a second rule that seems a little bit more difficult in terms of it having at least one extra step? Well, in general, the stuff that we're going to multiply by this constant on the outside of the parentheses, maybe inside the parentheses, we have a variable. We might have something like, let's say 3 times x plus 2y. And in this case, the variables in here cannot be combined because they're not the same kind of variable. Let's say that x represents apples and y represents bananas. I can't add 1 apple to 2 bananas and say I have 3 bananas. That doesn't make sense. But instead, if I'm saying that I had 1 apple and 2 bananas, and then I wanted to triple my cart at the supermarket, well, I could use the distributive property to do that by multiplying each of these terms in my set by the number out here. And so I would get 3x plus 6y. That is, if I tripled my 1 apple and my 2 bananas, well, I should get 3 apples and 6 bananas. Okay, so in general, the distributive property will typically be written out like this in a textbook. If you were to get your hands on a textbook or look at the ebook, the distributive property its definition is we let A, B, and C be real numbers. So they're placeholders right now for any number that you can think of. If I have the situation where I have A times B plus C, then I can convert that into A times B plus A times C. Again, distributing or multiplying that A by each of the terms in the parentheses as they're separated by that addition symbol. Similarly, if I had A times B minus C, then I can still distribute across subtraction as well. That would be A times B minus A times C. So 2 different sort of flavors of the distributive property. Now, you might want to be careful here because the distributive property works for multiplying a single number over an addition, a set of addition problems or a set of subtraction problems. If you have A times BC, that is simply A times B times C. So that's just a note. This is just multiplying. This is not the distributive property. Okay. So let's take a look at some workbook problems so that we can sort of get a feel for how these problems will work out. Yeah, let's do this. Let's go ahead and simplify these expressions. 6 times x plus 9. And let's just talk them out loud once you have them written down. -2 times 6x plus 6y. Seven times 5x plus 7y plus 8. Okay. So we're just going to use the distributive property to simplify, quote unquote, these expressions as much as we can. Does anybody know, or has anybody simplified the first expression already?
What did you say, sir?
Has anybody simplified the first expression already?
Yeah, it's like
got
6x.
6x plus 15.
Fucking treesh.
6x plus what?
54.
Plus 54.
Yeah.
Yeah. 6x plus 54. Is everybody okay with that? Or does anybody have any questions or comments or concerns? We're simply multiplying the 6 by each of the terms in the parentheses. Okay, what about the second expression?
-12x minus 12y.
Cool, perfect. Does anybody have any questions about this one? Okay, again, here we're just taking the -2 and multiplying it by each of the terms that are in the parentheses. So -2 times -6x should be -12x. Same thing is going on over here. We have -2 times positive 6y. So that should turn into a negative or minus 12y. And then finally, for the last expression, what should this simplify to?
35x plus 49y plus 56.
Is everybody okay with that? Okay. Well, now I have a few problems that I want you guys to solve on your own. So I'm going to open up the breakout rooms, but let me write these down. Some practice. And the instructions here are just going to be simplify the expression using whatever methods we've used for simplifying expressions so far. So the first one is -1/12 plus 9y plus 17/12 y minus 5 plus 7/12 y. The next one is 4p plus 2 times 6 minus 5p. The third one, let's do 9/7 times y plus 5 minus 3. And finally, the fourth problem will be -4/7 times, let's go with p minus 16 minus 1/14p. Okay, so I've opened up breakout rooms. Once you've written down the problems, you can go ahead and jump into the breakout rooms, and then we can work on these together. And then for the remainder of class, we can talk out as many of them as we can get through.